Hey, in this video, I'm going to show you how to build things with LLMs like ChatGPT, GPT-4. It's going to be cool. I have I think 5 big tips based on this big thing I just built that uses GPT-4. So this summer, well, I guess it's still the summer. And in the late spring, I went to Minneapolis for a get-together with everybody at Earthly. And we were staying at the Hilton Garden Inn. And we stayed in a boardroom there, brainstorming ideas. We also did some curling, which was fun. And I'd only done once before in my life, and it's surprisingly hard. I bruised my knee. Got to be careful with your knee, man. But yeah, one of the things that we wanted to build at Earthly was a way to convert from another build system to Earthly. A lot of people use GitHub Actions to do their builds. It's nice. It's right there in Git. You can use Earthly inside GitHub Actions, but you have to write an Earth file. And sometimes people don't have the time, or it's just not a big priority to do that. Once they do it, right, then they see some benefits, but they need to write it first. So the idea was proposed, let's use ChatGPT, let's use an LLM, let's do this conversion automatically for them. We'll make it that much easier for people to try out our cool open source project. And me, being pretty excited about such things, I volunteered to take it on. And it was a success. It took me a couple months of here and there effort, but we can now do that conversion. Along the way, I learned some things, right? I learned a lot about what works and what doesn't when you're using an LLM programmatically to do coding tasks, right? Anyways, yeah, let me give you my tips. Lesson number 1, maybe most important thing I learned, is about the scarcity of context. If you're using the ChatGPT API, and you're having these long dialogues and ChatGPT is answering it, you might not realize that there is a limited amount of context, a limited amount of information that it can take in and use to answer your question, right? For GPT-4, there is now an 8K token version, where a token is basically a word. So the information you give it as part of your prompt, including all the previous chat conversations and whatever it returns, all of that needs to add up to less than 8,000 words. The chat API kind of hides it from you because it just drops things as they don't fit. But this becomes a huge limitation when you start doing some sort of conversion task, right? Let's say you're trying to convert JavaScript to Python. If your file that you want to convert is more than 8,000 words, well, you have a problem, right? You can't send that all in, right? And if you need to provide extra information besides that, you got to find a way to make it work, right? You're always limited to that context window. And context windows are getting bigger. I have played around now with Claude 2, which has a 100K limit, which is, what is that? It's 12 times the size of 8K. But even so, this context is precious, right? You may have heard people talk about vector databases, where they take a lot of the context that you need to provide, they put it in this database and get embeddings and send those into the prompts. This is just a way to choose what to send in those 8,000 words. You still only have 8,000 words. So this is my first lesson. Context is important. You have to think carefully about what you're sending over, right? Because you're very quickly going to run out of size, and then you just get back an error. You sent me 9,000 tokens, and I can only accept 8,000. And then I won't even have room to answer because the context includes the response you get back. So that's it. Lesson number 1, context. It's your most scarce resource. Lesson number 2, knowing what it knows is important. GPT-4 knows a lot of things. You can ask it factual questions and it will oftentimes give you the right answer. Sometimes it won't, right? Because if it doesn't know something, it will just come up with an answer anyways. Knowing what the bounds are for that is very important, right? Here's an example. This was me taking just a very easy pass at converting from a GitHub Actions to an Earthly script. I said above this, you can imagine, I'm here's my GitHub Actions workflow, please write an Earth file. And it knows the basic format, although not in detail. And when it got to the line in the GitHub Actions that was a matrix build, it just converted that to an Earth file, right? It came up with this matrix keyword and it said, yeah, we want to run this on all these different OSs and on all these different Go versions. The thing is, there's no matrix keyword in Earthly. Earthly has a different approach to this where you would call it with different args, like a function call, right? Pass in the OS. So this is wrong. It's important to know what the LLM knows, right? Because you can lean on that. So obviously here, I can't just ask it to do a direct translation. I need to tell it more about Earthly. So my 4,000 word context window, I need to send in documentation about how Earthly works if I want it to successfully be able to do the conversion, right? The other thing to know though is that there's lots of things that this GPT-4 LLM knows very well, right? It very well knows how to write bash scripts. It very well knows how to write Docker files. And Earthly is very close to those two things. So by telling it in the prompt, oh, Earthly is like a Docker file, but with targets that are like a make file, it's able to lean on that information and get a lot closer to where I need it to be. So then I can send along less documentation, right? Because I know that it understands those concepts well, and it can understand my analogy, right? To say that, oh, it's like a Docker file and a make file had a baby. And it will know, okay, well, probably I can take these concepts. That's not enough to get all the way. But what I'm saying is, if you know the concepts it knows, then you're better able to direct it to have a solution. So the next thing that's important to know is how you can subdivide your tasks up. You only have a certain amount of context window, and you possibly have a lot to get done. Like doing this conversion of a large build script to another large build script, I need to find ways to split that up to make it something that's possible to be done. So one way I did this, because the gap between a GitHub Actions file and an Earth file can be large in some cases, was to do multiple steps, right? The LLM knows how to write a bash file, right? And it understands GitHub Actions pretty okay, right? And so I ask it, instead of going all the way to the Earth file, which you don't understand, let's go to a bash file first, which is close, right? So this is my first request. Like, here's this file, go to this format. And then I can split up, okay, from this file, we'll go to this format. And then let's improve that. This way I can slowly get towards where I need to go. It's divide and dominate. There's a number of more automated solutions to this that you may find if you look into the research. One is called Tree of Thought. There's also ones that just use steps. So if I need to accomplish X, you would ask the LM, like, what are the steps to accomplish X? And it'll give you like, okay, here's the 4 things. And then you say like, okay, get the text of the first one. Say like, do this. And then it does that. And okay, do that one. And then it does the next one. And you're kind of asking it, right? How can I split this up? And then you're asking it like, okay, do each part and then somehow synthesize. But this is important, right? If you want to do a large task, right? Doing a large conversion of a large project instead of just a single file from JavaScript to Python, right? You need to come up with a solution, right? Like, can I go file by file? Can I say like, okay, convert this file to Python, convert this file, or maybe like function by function, How can I chunk this up and ask it to convert each one and then somehow synthesize these at the end into a larger solution? Think of how the tasks can be divided up into chunks, right? How would you handle as a person if you had to do this step manually? Like, how would you subdivide it? Maybe there's a great way that you can use that same subdivision with an LLM. Okay, next tip, messaging the machine. People often talk about LLMs as something that predicts the next token of some text. That is absolutely true, right? And it even will do more than that. It will tell you, the most likely token to come next is this, but the next most likely after that is this. And so you can sample from various answers. So that's true. But it's not particularly helpful when you're trying to design prompts to come up with a solution. And so what I found helpful is to imagine that you're emailing like just a junior, maybe a junior engineer in my case, because it's a coding task. How can I describe the task that I want them to do in an email, right? And provide all the important information that they might need. Because this junior has, a very large width of knowledge, right? But lacks some of the specific depth. So what information do I need to provide along with it, right? I want you to do this task, right? And do it this way. I want you to take this GitHub Actions file and I want you to write a bash script that does the equivalent. Oh, and by the way, don't install things in the bash script because we're going to run this in a Docker file. And yeah, why don't you write the Docker file as well? And oh, here's an example one where I've done the conversion. Maybe you can follow along. If you start thinking like this, how you would get somebody else to understand this task and what information you could provide to them, knowing that they couldn't run it at the end, right? Knowing that, they don't have access to Google. It'll give you the right kind of scope for the information that you need to include, right? It's more than just, hey, do this conversion. It's like you want to provide everything that they need. Because if you don't, the LLM will just come up with an answer anyways. So that I call messaging the machine. I just try to think of the machine as somebody I'm writing an email to with a task. And I found that made it a lot easier to understand what information is needed. Okay, next tip, thinking out loud. This one may be the most important one. Early on, I noticed when doing the conversions that sometimes the GPT-4, which was the main LLM I was using, it would take a lot of time to get back. Sometimes it would be very fast. Sometimes it would take a minute, like a literal minute, which is a long time for an API call. And I thought, well, that's obviously just a harder thing I've sent it, this question. So it's taking more time to think about it, to think about like what the solution is. Interesting, right? But totally incorrect. LLMs, they don't have an internal dialogue. They don't sit there and think about something before coming up with a solution. If things are slow, it's just because it's slow. Like maybe there's a job queue or who knows. But the LLMs spend the exact same amount of intelligence or thinking on every token that they emit. They don't have an internal dialogue. And because of that, there's a very straightforward way to get a more intelligent answer from an LLM, which is just have it use more tokens. So you ask it to think out loud. This is often called chain of thought prompting. But instead of just asking it for the answer, you can say, think it through. Tell me how you're thinking of approaching this. And then it'll tell you a lot more, right? It'll give you a small essay on how it's going to think through the problem. And then ask it for the answer, and you'll get a better answer, right? I mean, the API costs will be more because you're paying per token, but you're getting a better thought process out of it. I found this super helpful. Like just doing this step will make whatever LLM you're using seem just that much more intelligent. And so for my case, for the GitHub Actions, what I would say is instead of converting this GitHub Actions exactly to Bash, I said, at first I would say, let's go through it line by line and tell me how you would approach converting each line. And it would, okay, this line I'll do this line I'll do that. I got to run this command. And then I'll say like, okay, now make the Bash script. And then it would be better than if I just told it to immediately create it because it had time to think it through. So there's a whole bunch of variations on this idea. I think if you understand that you can get a better answer by just like spending more tokens, there's a lot you can do. So one of them is called expert prompting. So you'll see it where it's like, okay, what's the best way to learn drawing? Instead of just getting an answer, you can say like, okay, what are three great artists? And then, okay, answer what they would give, right? Like what would Da Vinci say is the best way to become good at drawing, at art? And okay, what would the other artists say, right? And then a third one. And then you would say like, okay, given those three results, like, can you make a combined answer that explains the best way to get good at this? And that will give you a better answer than if you just asked for the answer straight up because it spent more tokens thinking through it. I mean, I'm sure the kind of LARPing as Da Vinci helps as well, but it's just a creative way to get it to think about things in a unique way. There's another approach called critique prompting where you just, okay, come up with the solution and then you ask it to critique its own answer. What do you find wrong with this? How would you improve this? Is there any mistakes here? And we'll list out the mistakes and then like, okay, now using that, can we update the answer based on your critiques? And so that's a nice way to further just get it to spend more tokens, find its own mistakes and correct them. I actually did a little bit of this in my project. After I generate a working Earth file, I would give it some more earthly documentation. And I would say like, okay, is there any places where, this isn't idiomatically correct? Like list them out. And I would say like, okay, we'll fix that. Right. And I would get a better solution at the end because I was saying like, okay, spend some time thinking about if there's any way to make this more idiomatic, which is a useful prompt for a human too, right? Like, hey, here's my Python code, but is there any ways that I could make this better? And oftentimes you'll come up with better ways, right? A super neat approach to this thinking out loud is structured chain of thought. So I have this example here from Microsoft Guidance, which is just a nice library for prompting LLMs. The idea here is they want to ask GPT-4 about anachronisms. I want to, given a sentence tell me whether it contains an anachronism. An anachronism means that the thing is not properly time-based, right? Like if I were in the 1500s and I had a smartphone, that would be an anachronism. So you could just say, here's a sentence. Is it an anachronism? Yes or no, right? But then it's only spending one token on it. It doesn't have time to think through the solution. So you'll get a better answer using an approach like this. So first they give a sentence, right? I wrote about Shakespeare. They ask the LLM to identify entities and dates, right? Think through what entities and dates are happening here, right? And then give me reasoning about whether or not it's an anachronism, what you think, right? And then give me the answer, right? And so giving it time to work step by step. And this approach here is actually a few-shot chain of thought prompting. So they've basically given two answers, right? Where they've shown it. This is how I would think about this problem. I wrote about Shakespeare is the sentence. I would identify these two time periods. I would think about it this way and say it's not an anachronism. Shakespeare wrote about me. Here's how I would think about that, right? It's the same entities, but the ordering is reversed. And so now I say, yes, it's an anachronism. And so we give this whole thing, right, down to here as a prompt to the LLM. So this is the few shot part. This is the chain of thought, right? And then it's able to answer arbitrary questions about whether they contain anachronisms or not. And it's able to do it better because you've given it time to think these results through, right? To pick out the entities and the reasoning, and then give it a label. And so this just using this technique, oh, so amazing, right? Give it some examples, have it think through things, and wow, you'll just get such a better result. Okay, so I have two tricks left. The last one I'm calling no trust without truth. If you are up on LLMs, people are often complaining about them hallucinating, which is true. If you ask it something it doesn't know the answer to, it'll probably just make up an answer. So that's something you have to keep in mind, but there's often, depending on what you're doing, an easy way around it. I'll give you an example. We know that you shouldn't just ask it to come up with the answer to something. You should give it some space to think it out. So if I'm writing a speech and I want to make it funnier, instead of just saying, here's my speech, make it funnier, I could say, here's my speech, how would Jerry Seinfeld say it? Here's my speech, how would Dave Barry say it? Here's my speech, how would Amy Schumer say it? And I would say like, okay, well, take some of those jokes and put it in my speech. And here's my updated speech that now has some jokes, right? So that will work better. But all the jokes might not be funny because LLM doesn't have a sense of humor, right? It doesn't know what is funny or not. And so there's no way to validate those jokes except, like reading it over and trying it on other people. You need ground truth to test these things, right? That's hard with humor. Like you have to try it out. I could try it on my wife or go to a comedy club. But for things like a programmatic task, it's not that hard, right? If I'm converting JavaScript to Python, I can just run the Python and see what the result is, right? I can validate the result and then feed that error back in. Or in my task, I take the GitHub Actions, generate an earth file, and then run the earthly parser. And so here's an example. When I asked it to do this conversion of an earth file, just using the ChatGPT API, it came up with this save cache and load cache command, right? Like this. And earthly does have a cache, but these are not how you call it. That's made up. But it doesn't matter because when I run the parser, I get an error that says like, we don't recognize load cache. I can feed that back into ChatGPT, into GPT-4, and have it correct things, right? So hallucinating is less of a problem because you can validate things because I can run the code and find out what's happening. So that's an important thing to think about. But when you're trying to say like, could I solve this problem using an LLM? Well, can I validate whether the result is correct or not? If you have a use case where coming up with the solution is hard, but validating the solution is easy, also known as an NP complete problem, LLMs really good at this. They can be easily validated, right? They can come up with the solution and then you can check it. So that is why I say no trust without truth. You need the truth, the ground truth to validate what it's saying. All right, one more tip left, which is taming troubles with thought chains. I was trying to come up with alliterations, but that one doesn't totally work because thought is not the same sound as taming troubles. Anyways, if you're doing a conversion, you're converting JavaScript to Python and it keeps coming up with an incorrect conversion for like generators or something Python-esque. You may wonder like, what do I do? How do I tell it to do things the right way? And the answer is simple. You can just use this chain of thought prompting to do so, right? So here's an example of how you might do that, right? When I ask it to convert a GitHub Actions workflow to a bash script and go line by line, it generates its chain of thought, right? Here's some of it here. It was missing a step, right? It was trying to convert this on command in the GitHub Actions workflow into something in bash, calling some sort of on trigger thing that doesn't exist. And so I took its thinking and I edited it, right? I put in its thinking a new thing, we should ignore the on section. And then I can feed that back in the same way we did here, this few shot prompting. I can feed back in my updated reasoning, right? And so the next time when it hits a different example and it still has that on section, it knows from these previous things how it should deal with that, right? They're much larger than this, but you can edit its thinking, feed it back in as a few shot example, and then it learns from its mistakes. It's the same way with the junior programmer. You send him an email, you say, do this conversion. He comes back, he makes a mistake. And you say, well, look, actually, when this happens, you should do that. Except because your junior programmer in this case only has that small context of memory, you have to send that along the next time, right? You update your instructions. Here's all the instructions. And remember, when this happens, do this. That is a way you can debug. When the thinking goes wrong, you can debug it because the thinking is kind of thought out loud in text. So you can read what it's thinking. And then you can alter it and send it back on future goes. So you kind of iterate that way until you run out of context, right? You still only have so many characters to send back your feedback. But man, you can do a lot in 8,000 characters. And then if you switch to Claude 2, which doesn't seem quite as smart as GPT-4, but has so much reasoning, you can feed it a lot of answers. So those were my tips. I forget if there's 5 or 4 of them. I think 5. So one is just pay attention to the context, like how much information you're sending. Be very selective about what you send because you only have so much space. And you need to use that space also for the LLM to think out loud and for the actual result. And if you're doing any corrections, to send it, specifics. Also, one way to deal with that is try to frame the problem in terms of things that it knows, right? Try to break down the problem into various steps, right? Maybe you go file by file, maybe you go chunk by chunk, and you somehow can synthesize those back at the end. And finally, use thinking out loud so that it can think through every step. And you get like a much smarter result, especially if you use this few shot thinking out loud with corrective feedback, right? That's my last tip, is you can provide corrective feedback through that few shot chain of thought prompting. Combine all those things together, you can do a lot with GPT-4. You can do a lot with Claude 2 or Anthropic and maybe some of the open source ones. And who knows what's coming next, right? Maybe some of these techniques won't be needed, or maybe you'll be able to use these techniques to push things even beyond where they currently are. Yeah, so that's my tip on building something with LLMs. The thing I build is called build transpose. It'll transpose a build from GitHub Actions to an Earth file. Maybe I'll add more things I can transpose from. In the future, you should check it out, especially if you use GitHub Actions and you want to try out just a better way to build things. Also, you can just look at the code because it has a lot of examples of how to do these, chain of thought prompting, how to cache the results, how to build on this really cool tech. Yeah. So you should check that out. And let me know your thoughts. And thank you for watching my video.